Good morning, good evening, good afternoon, depending on where you are. Welcome to Percona Live, which unfortunately is not live. Hopefully next year we'll get back to Austin or wherever they decide to hold it. My name is Dave Stokes. I'm a MySQL community manager. I've been on the community team for over a decade, and I'm talking today about JSON validation. Now, MySQL's had a JSON data type since version 5.7. And it's very useful, very informative, but there are some things about JSON that people don't like. We'll get into that in a minute. Before we start, a quick background on me. If you need to get a hold of me, on Twitter, I'm at Stoker. Email is david.stokes@oracle.com. The slides are available for this presentation at slideshow.net/DaveStokes. Just look for Percona Live 2021 MySQL JSON Validation, and that should pull up this version. I also have this posted up on YouTube. I'm sure the Percona folks will get this out there as soon as possible on their stuff too. So, JSON. What the heck is JSON? Well, JSON has been around for quite a while now. It came originally from JavaScript object notation, and that's what it stands for. There's two standards for this. Both are very short. You probably read them both in under half an hour with a coffee break in between. It's an open standard file format, and it's very easy to read, designed to be human readable. Things like XML and SGML in the back history weren't so much, so it's probably made JSON easy to implement, and it's become very popular. And if you haven't seen JSON before, this is an example of a JSON document. As you can see, it's very easily readable by humans, very easy to parse. The heart of it is keys and values. So like we have GNP, which is the key, and then the value. You can also see that we can have keys that have other embedded stuff in there, like we have here for government or geography. So the geography is actually embedded in all this, government's embedded in all that. And by the way, the documents, if you haven't noticed, are enclosed in curly braces. By the way, you can have both objects, which are demarked by curly braces, and arrays, which are the square braces, within your JSON document. MySQL does not have a native a native array type, and a lot of folks are using JSON for that. Kind of mixed feelings about that, but it can be done. And the great thing about JSON is it's pretty much free form. If you can get it in there, you're allowed to do it. Now, MySQL, you have a limit of roughly a gigabyte payload, so your document has to be about a gigabyte. Now, relational databases, as has been there for the beginning for the past 40, 50 years, is strict data types. You have integers, you have characters, you have decimals, you have other data types out there that are pretty much only for what you want to put in there. True, you can put an integer value into a car, but you can't put a car into an integer. Also, you can say that certain fields are required. You have to put a value in there. So saying, hey, this can't be null, you have to have something in there. You set up default values, so if the value is specified, it will plug something in there for you. And also, you can have constraint checks and range checks. So this gives you type checking, range checking, default value checking, and all that. This is something that traditionally hasn't been there in JSON. Now, the good thing about this is that by having these strict checks, you can make sure that the bad data doesn't get into your database. It's very much easier to keep the bad stuff out than to realize you have bad stuff in there, go hunt it down, go correct it, and republish. That can get very expensive. So we have the strict form of the traditional relational database, and then we have the free form of the JSON. Kind of an impedance mismatch there. Well, what if it wasn't? What if you got the benefit of both worlds? Here's another example of how JSON's freeform can hurt you. We'll go into the benefits in just a little bit. So, let's say like you have a dozen programmers and they're storing email data and they're using JSON and no one's really set out a guide on how you record stuff. And we have a key value pair of email. Well, someone might be saving it as email, all lowercase, E uppercase M mail, E dash mail, electronic mail, EM mail, small email, and many variations of this. Now, freeform, these are all valued. or valid, but if you're going to search, you're going to make a conscious decision to go out there and search for everything that's a variation of email. You might have a programmer like me that fat finger stuff, and it just might start with M-E-A-I-L. So this freeform can be a little dangerous. Now here's some examples of keeping data clean the traditional way with a relational database. We're going to create a table called Percona, 2 columns. ID is an integer. We have another one called name, a car 25. We go to insert into that new table the values of test. We haven't specified a value for ID. And it's going to come back and say, hey, you're missing a row. That's what column count doesn't match value at count row 1. Create another table called PZ. Once again, integer ID, name car 25, not null. We try to insert the ID without a name. The server comes back and says field name doesn't have a default value. So this is examples of the database keeping bad stuff out just by the definition of the table. Now we can also have a constraint check. In this example, we're creating a table called check_PLZ. We have a column called C1, and we have a constraint check. We're checking to sure that C1's value is not 42. And we try to be a little creative by having a default value of 42. And you'll see how that bites us in just a minute. We have a second column called C2. So we go to insert data in there, and we're just giving the value for C2. It comes back a constraint check saying, hey, you're trying to enter a bad value. So once again, this is trying to keep bad data out of your database. So you've designed this table to know that you don't want the value of 42 in there. And you're doing all you can to get around that. But as I mentioned earlier, what if there's a way to check the JSON data, which being freeform doesn't have natively, and ensure that bad JSON data is not going to get into your database? Well, the wonderful folks at jasonschema.org have come up with a way to do just that. You have a template document, an exemplar, that you use to test your new document coming in. So you're doing a comparison of what's in the template to see if your data matches it. If it doesn't, it gets rejected. So this was added in MySQL 8.0.17, and that's 2 functions, very simple, and it's well worth reading the section 12.18.7 on this function, and I'll give you some examples. The functions themselves are fairly simple. JSON schema valid, where you have your schema that you want to test against, and your incoming document. Now this does take that document and compares it to what's in your definition schema and compares them. Now what's coming in has to be a valid JSON document, obviously. If you're trying to input a improper JSON document into MySQL by default with the JSON data type, it rejects it. Now, if your document matches up with your exemplar schema, it will say, hey, it does, so it's going to return a 1. If it doesn't match, it returns a 0. Second function we want to talk about is JSON schema validation report. You get that 0 and you want to know why it didn't match. Well, what you can do is run this function and it will come back to you and it will tell you what exactly went wrong. I'll have an example of that in just a moment or two. So, simple example number 1, the exemplar, the new document, and the test. So, we've set up a JSON document and we say, okay, what we have is we're going to bring in an object. The properties of that object is that it's called myAge. That's the key of it, or what I call the name. And that object is a numeric data type, and it has a minimum value of 28 and a maximum of 99. So we have a second document. This is our actual document we're coming in, and we have our field, myAge, the key. In this case, the value is 33, which is between our minimum and our maximum. So when we run the test, select JSON schema valid, our exemplar and our document, it comes back and reports a 1. Yes, this is a good document. It will go into the database if you do that with a insert statement. Example number 2, going to change things just a little bit. Once again, Our exemplar is the same. We have an object named myAge that's numeric, and the value is between 28 and 99. But in this case, we're bringing a document, and the age is foo. We run our select JSON schema valid function, and it comes back with a 0. Doesn't match what we requested. Okay, let's look up example number 3. This time, our exemplar, once again, is still the same. Still the object with the properties of myAge is the name, and it's numeric, minimum 28, maximum 99. And this time we try to check it against the document where myAge, the value is 16. And since 16 is less than the minimum value, it returns a 0. Now the other function I mentioned, the JSON schema validation report, I recommend piping through JSON pretty, because the output's in JSON and it's not easy to format, not easily formatted for the human eye. So please pipe it through or enclose it in JSON pretty. Now that last function we did, where we tried to input a value that was way below the minimum, it comes back and it says it was not a valid document. The reason? The document location, myAge, failed the requirement for the minimum value. And it was for the myAge key value pair. And it tells me what the key it was looking for. And it failed because it didn't pass the minimum. So it's very easy to go back and check our exemplar document and see exactly what the values were and see why it failed. Now, if you want a required field, all you have to do is add another property saying this is required and give the key that you want to have required. Now, this is in a constraint check. So in here, we're creating a table. We have a column named COL, very creative there, Dave, of type JSON. And we're saying, okay, we're going to have a constraint. And the constraint we're going to call myAge in range. By the way, when you create constraints, I recommend giving them a name. Otherwise, you get constraint number 4 failed. Well, what's constraint number 4? That doesn't give you an obvious clue. Now, in this case, we're going to run this check through the function. In this check, we're going to run the check using the function JSON schema valid. And there again is our exemplar document embedded in the definition of the table. And if the check doesn't return 1, the constraint fails. So we try to insert some data. In the first one, insert into the table values myAge 27, and the constraint myAge is violated. Why? Well, once again, it's under the minimum. Now, if we try to give it a valid value, insert into text values myAge 97, and it goes. So this time the server is doing the check for you, and it's actually checking to make sure that it is a valid schema document and that that document has a key of myAge and that it is a numeric value and it matches a value between our minimum and maximum. And with that, that is the highlights of this talk. And I'd like to encourage you that if you want to learn more, please go out to the MySQL manual. There's probably about 2 pages of stuff on the JSON validation functions with a lot of examples. Really, really well worth reading if you're going to get into this. If you want to understand the JSON schema better, they actually have a nice little tutorial out there. Highly recommend going through that. Also, if you want a better look at these examples and some more explanations, my blog, elephanttolphin.blogspot.com. Back in July 2019, I did a blog on this. By the way, to pay for my time to be here, Oracle would like you to know that you can test drive the MySQL database service, what we call MDS, for free today. Get $300 in credits, which if you stick to the low-end configurations will last you quite a long time. You'll get the latest and greatest version of MySQL, and it's free. Go out there and try the MySQL database service. Also, you're part of the MySQL community. Stay in contact with us. MySQL.com, Twitter, we're MySQL, Facebook, we're MySQL, LinkedIn, we're 20,000 strong on the MySQL group there. And also, please join us on mysqlcommunity.slack.com. By the way, if you're working for a startup, Oracle has a program for startups where you get amazing discounts, credits. They'll help you with marketing, doing stuff at events, and it's well worth it if you are a startup. So if you are a startup, please go to oracle.com/startup. And if you're really interested in the JSON data type, the second edition of my book, MySQL JSON A Practical Programming Guide, is available off Amazon. This goes into a lot of background on how to use the JSON data type with a lot of practical programming examples. I always like the books that were half tutorial, half reference manual, and this is more on the tutorial side. So if you are working with MySQL and JSON and want more explanation how things are going and some best practices, please get a copy of that. And with that, let's go into question and answer. Once again, david.stokes@oracle.com if you want to email me. The Twitter handle is @Stoker, and once again, the slides will be up on the Percona site, plus slideshow.net/Dave Stokes, and hopefully I'll also have this video up on YouTube very shortly after the show. And with that, thank you for joining me today. I hope you have a pleasant rest of the show, and hopefully next year we are in person. Thank you.